this video we'll be discussing third property, that is derivatives of a Laplace transform. So this property states that if Laplace transform of some function, that is t, Laplace transform of t, f of t, if it is equal to f of s, that is function of s, then then Laplace transform of t power n f of t will be equal to minus 1 raised to n, minus 1 power n dn by ds power n function yes. So basic thing you have to remember here is that, see, if Laplace transform of some function which is equal to f of s, same in case of what first shifting property. The difference is that instead of e power at, here it is t power n. Okay, when product of t power n with some function comes, then what you have to do? You have to do this in this way. The format becomes what this. So minus 1 raised to n, where n is nothing but positive integer. N will come from where? From here. If it is 2, you have to place it 2. So d by ds raised to power n, here also n. This means what? Derivative. Okay. If here it is 1, you have to differentiate the function whichever we have. Okay. You have to differentiate 1. If it is n is 2, you have to differentiate twice. If it's 3, you have to differentiate thrice. So in order to understand this, in order to analyze this, we will try to take one simple example to analyze this question. So we'll take one example. Okay. So if Laplace transform of t cos at you have to find, suppose. Okay, this is a basic question I have taken. Now observe here, t into some function. So we have to think about derivative property. Okay, that is this property. Okay, this property you think. Now t power n is there, right, in the standard formula. So t power n is there, so n is nothing but here 1, right? Nothing is there, that means t power 1 is there. So n becomes what? 1. Now Laplace transform of this. So compare this and this. See, Laplace transform of what? This function, that means t power n into f of t. F of t becomes what? F of t becomes cos at. First thing you have to look for n, then you have to look for what? F of t. This whole term is not f of t. Compare this and this, not this and this. Okay, compare this and this. T power n, t power n, t power 1 is a f of t, which is here cos at. Now we got f of t as cos at. Now what you have to do? If Laplace transform of f of t, that means you have to find the Laplace transform of f of t. In case of first shifting property also we have done the same. Okay. Now Laplace transform of function, that is here it is cos at. So Laplace transform of cos at, we know the standard formula, that is s by s square plus a square. So it remains as it is. Now t power n. Now we got this is nothing but what? Function of s. A is constant here. Okay. Now what you have to do? Laplace transform of t power 1 cos at you have to find. So what that means? Laplace transform of t power 1 cos at becomes what? This thing. That means minus 1 raised to how much? Minus 1 raised to 1, because n is 1. d1 by ds power 1. That means one time you have to differentiate. What you have to differentiate one time? F of s. F of s is nothing but Laplace transform of f of t. F of t we have found out, that is this. So this thing you have to differentiate, not the cos at. Remember, always remember, f of s is Laplace transform of function of t. So Laplace transform of f of t is nothing but this. Okay, that we have found out. Now you have to differentiate what? This term s square plus a square. This thing you have to differentiate only once because power 1. So differentiate only once. Now, in order to differentiate, what rule we will apply? U by v rule we can apply, right? So u by v rule. So I'll do it somewhere here. Okay, just rub off this part. Oh, this thing. So we got Laplace transform t power 1 cos a t, which is equal to minus 1 raised to 1 d pi ds1 s by s square plus a square. Okay, you have to differentiate this part, that becomes minus 1. That means minus 1 only. Differentiate this, that becomes first into v by v. This is u by v rule. Okay, u by v rule, this part. So v into derivative of what? U 1 minus u as it is, that is s, into derivative of v, that is the denominator, that becomes 2s. This is constant, it becomes 2s, right? This becomes 0 because this is constant, by v square, that is 2s square plus a square, the whole square, right? Now you can simplify this. So this becomes what? Minus s into 2s, that becomes minus 2s square. Minus 2s square here. Okay, I'll just do it. This becomes minus 1. Okay. Now s square is there, plus a square, minus this becomes 2s square by s square plus a square, the whole square, right? So s square minus 2s square, that becomes what? S square minus 2 square, this becomes only s square, right? Minus s square, so this becomes minus s square. Okay, try to analyze this. So it was s square minus 2s square. Okay, s square minus 2s square is nothing but minus s square. So this is minus s square. A square remains as it is. So the answer is nothing but, so minus is there, you can take inside, this becomes s square minus a square by s square plus a square, the whole square. This is the final answer. So try to analyze. Okay, so first thing you have to find n, then f of t Laplace transform you have to find, then in place of, not in place, you have to use this formula, that is minus 1 raised to n d by ds raised to n, that and all, that formula you have to apply and find the answer.